Holy cow, welcome to video number 151. I don't even know how many videos this is over 1-13 Unit 1 test, but hopefully you'll find something in these videos which will help you better understand anything that might have been confusing for you on the test. Video 151 picks up with question number 60. So here we go. Let's move to question number 60. And question number 60 starts off dealing with this particular thing right here, where we have positive ion, sodium, that's a cation, being pulled together by chloride. Notice how the sodium positive has 3 negatives around it. This sodium here is surrounded by negatives. These chlorides are all surrounded by positives. This thing is being held together by the attraction of opposite charges. Where did these things get their charges? Well, the sodium had electrons. Each of these sodiums had electrons that were stripped by these chlorides, which took the electrons. Electrons are negative. The thing that took the electron becomes negative. The thing that lost the thing that was negative, the electron, is left positive. But once these charges have been transferred, that is an ionic bond, we form these ions. The positive ion's a cation, the negative ion's an anion. Positive, for cats have paws. Or you could say cation has a T in the middle, which is a positive sign. The chlorides have negatives. That negative sign, the first letter of negative is N. Anions have an N in the middle of the word. Now notice, when these charges all line up, when these oppositely charges line up, we can't tell who lost the electron to who. And in fact, none of them can go around individually. If this sodium moves, these 2 chlorides go with it, these 3 sodiums go with it, those 4 chlorides go with it, those 5 sodiums go with it. They cannot move around individually. This is not a molecule. In a molecule, you can tell who was with who. We can't tell. Was this sodium, which chlorine was this sodium originally with? Which chlorine, which is now a chloride, took the electron off the sodium? You can't tell. So with a molecule, they can move around individually. With this crystal lattice, notice it looks like a lattice. If you've ever seen a lattice fence has the slots all lined up. Some wood going this way, some wood going the other way. Notice these chlorides have all lined up one way. The sodiums have all lined up the other way, like a lattice. Thus the name crystal lattice. All right, let's take a look now. Sodium's the cation. There's a positive sign. There's the positive sign in the middle of cation. A T looks like a positive sign. That's true. The diagram's a molecule, 61. No. A molecule, they would be able to break off and move around on their own. With the crystal lattice, where one goes, they all go. This is not a molecule. This is a crystal lattice, which is a regularly repeating pattern of positives and negatives. False. 62. False. The ions are sharing electrons. No. Ions come when an ionic bond forms. An ionic bond is when the electrons are transferred. The one that took the electron had the electron transferred to it. Electrons are negative. They become negative. The one that had the electron removed from it, the one that transferred the electron to something else, is positive. So they're not sharing electrons. If they're sharing electrons, there would be no charge, because you have to transfer a charge to have a charge. 63. This is a compound. Absolutely true. Compound just means 2 or more different elements joined. Here, the sodiums have joined with the chlorides. That's a compound. The thing would be pure. 64. Is this thing pure? Yes, it is pure. You might be like, no, pure means one thing. Well, this is one thing. This is sodiums that have joined with the chlorides. It is sodium chloride. If you dump sodium chloride out on the table, it's table salt. If you dump table salt on the table, the only thing that is there is table salt. The sodiums have joined with the chlorides. They're bonded together as one thing. It's sort of like a marriage. You know, if somebody gets married, a husband marries a wife, they've become one. They are now a couple. Pure just means one thing there, sodium chloride. If I pour water, if I pull the sodium chloride into water or pour water on it, the water could dissolve the sodium chloride. But now we would have two things there. We would have the salt dissolved in the water. So we would have salt there and we would have water. That would be no longer pure. That would be a mixture. Pure can be a compound if you only have one compound there. If you have more than one compound there, then it's not pure. 65. The substance in the diagram above would have chemical and physical properties similar to chlorine, and sodium, which are making it up. No, no, no. Compounds have properties very different than the things that make it up. Sodium is a silvery, soft, highly reactive metal. Chloride is a yellow, poisonous gas. When they join, the sodium is no longer a silvery, soft metal. The chloride is no longer a gas. They form a very brittle solid called a salt. Metals are bendable. A salt is very brittle. It's not bendable. Their properties change. Chlorine is a poisonous gas, but when it forms table salt, if you stand over table salt and try to breathe it, you will not die. Now, if you breathe sodium chloride into your nose, it might irritate your nose. You might sneeze the sodium chloride back out, but it will not kill you like chlorine gas can. Chlorine gas was used in World War II. The properties change dramatically. The bracket right here, this bracket right here shows a formula unit for number 66. Yes, we've mentioned this before in a previous video, but a formula unit is what shows the pattern of the crystal. The pattern of the crystal is positive sodium, negative chloride. Oh, positive sodium, then a negative chloride. A positive sodium, a negative chloride. A positive sodium and a negative chloride is the pattern to this crystal. So this bracket is showing you the formula unit. Number 67, the empirical formula of the substance is NaCl. The empirical formula gives you the ratio that they've joined. The empirical formula is the ratios of sodiums to chlorides. In this crystal right here, for every one sodium, there is one chloride. So the formula is NaCl. You don't write Na1Cl1. It's understood to be there. Now, if there were two chlorides for every one sodium, then the formula would be NaCl2. You're just looking at how many are in there, how many of the sodiums there are for how many chlorides there are. Number 68. If the substance in the diagram was dissolved in water, and it would be, because sodium chloride does dissolve in water, it would be an example of a chemical reaction. No. Dissolving, this is false. This is not true. This is definitely false. If a substance is dissolved in water, it would be a physical change. It would be a physical change, not a chemical change. If water dissolves it, what that water does is pull the sodiums apart from the chlorides. It just separates them. So the sodiums are floating around and the chlorides are still floating around. If you evaporate the water away, the sodiums, which are positive, would pull the chlorides right back together again. So when you make salt water, the salt is still there, the water's still there, you can separate them again. So that would be false. It would be a physical change. 69 to 74, the nucleus contains protons and electrons. That's false. The nucleus contains protons and neutrons. They're in the nucleus. The electron cloud is mostly the empty space surrounding the nucleus where the tiny electrons can be found moving randomly about. That is correct. What an atom is a highly dense nucleus, a tiny little nucleus where the protons and neutrons, which are the bigger subatomic particles, packed together very tightly. Then the rest of the atom is just empty space where the electrons are flying about in random three-dimensional orbits. That's called the electron cloud. The part of the atom in forming chemical bonds are the neutrons. No, chemical reactions involve the electrons. When a chemical reaction happens, two atoms might share electrons. That's a covalent bond. They might transfer electrons. That is an ionic bond. The third type of bond are where the nuclei from the different atoms allow all the electrons to wander freely about. That's a metallic bond, where the electrons can move from atom to atom as they see fit. The electrons are free to move. They're delocalized. They can move wherever they want. The part of the atom in chemical bonding is the electron. The part of the atom in the formation of bonds is the electron. False. Electrons are negatively charged. That is true. The protons are neutral. No. False. The protons are positive. The neutrons are neutral. The identity of the atom is determined by the number of protons. Absolutely, that is true. The identity of an atom is determined by the number of positive protons in the nucleus. That is why the alchemists could not change one atom into another atom. They could not change copper into gold with chemical reactions, because chemical reactions involve electrons. In order to change one atom into another atom, you would have to change protons, and that doesn't happen by chemical reactions. That happens by nuclear reactions. Number 75, the sharing of electrons between two atoms. What kind of bond is it where they share electrons and the electrons are held between the two atoms? They're not allowed to move. They're held in that localized spot. That's called a covalent bond. Co means jointly. Valent means outermost electrons. The electrons in the electron cloud that are furthest away are the valence electrons. So covalent electrons means they're sharing those electrons jointly between them. Co means jointly. Valent means sharing between them of the valence. So that would be covalent bond, letter B. Electrons are shared between all the atoms, and the electrons are free to move from one atom to another. What is that called? When the electrons are free to move from one atom to another atom, they can move around. So you have an atom here, an atom here, an atom here. And those electrons can sit and go from atom to atom to atom. That's when a metallic bond is. And we talk a lot about metallic bonds later in the year. And finally, the third one, the transfer of electrons from one atom to another. Electrons are negative. The atom acquiring the negative electron becomes the anion. The N is negative. The N stands for negative in there. Remember, N in the middle of the word is negative. And the atom losing that negative electron is left positive, becoming the cation. That's what an ionic bond is. We're going to finish this video right here with question 77, and our next video will pick up with question 78. Thanks for watching.